Yes, welcome you all for another presentation on signal systems subject, and we are seeing the classifications of signals. We have started in the last presentation that what is a signal and what are the classifications of signals we have seen, and we have seen some important classifications of signals. If you recall, those are periodic signal and a non-periodic signal, as well as energy signal and then power signal, and then even signal and then odd signal, right? Deterministic signal and then non-deterministic signals. These signals what we have seen. And again we have seen some examples on periodic signals. Means that for any given signal we found out that whether the given signal is a periodic one or not. In this today's presentation also, I would like to bring you some more examples on to determine whether the given signal is a periodic one or aperiodic one, that we are going to see in this presentation with some more examples. Let us go into the subject and we will solve some more examples for your better understanding. Okay, let us consider one example, that is x of t is equal to 5 cos 4 pi t. This is the given signal. It is a continuous time signal because x of t is defined over small t, means it is a continuous time signal. X of t is equal to 5 cos 4 pi t. If the signal is given like this, now you need to find out, is it periodic one or otherwise they will be asking you to find out what is the fundamental time period of this given signal, right? So you can call this as equation number 1 here. And now the given signal, so the solution part I will explain. So in the solution part, what we have to do is that, what is the given signal? It is a 5 into cos, means it is a cosinusoidal signal. What is the standard form of the any cosinusoidal signal? It is very simple. X of t is equal to a into cos omega t. This is the standard form of the cosinusoidal signal. Or otherwise, if you write further something, it is a into cos. What is omega? You can expand here, no problem. Omega is nothing but 2 pi f into t. Clear? If you write x of t is equal to a cos, your omega angular frequency is equal to 2 pi f. Clear? Omega is equal to 2 pi f into t. This is the standard form of the definition of for this cosinusoidal signal. Now call this as equation number 2. Now the given problem or the given signal x of t is, this should be made equal to with this the standard form of the definition, means we have to compare the given signal with its standard form. Therefore, so I already told you in the previous presentation that so you need not bother about the magnitude values. So here 5 is the magnitude, where if you compare that with the standard form, here a is the magnitude. You forget about the magnitudes. Then what is the remaining part? So it is cos 4 pi t and then it is cos 2 pi f into t. Now compare these two from equation 1 and then equation 2. Then you will have, what you will have actually? It is cos 4 pi into t is equal to, what you will have? It is cos 2 pi f into t. Am I clear? If you equate equation number 1 and then equation number 2, then this is what you will have. On both sides, the cos term as well as cos term will get cancelled. Similarly, the time t and time t will cancel out, and pi and then this pi is also cancelled out. What remains here? 4 is there, on right side 2. So 2 ones are 2 times. Clear? Therefore, what you will have here? It is 2 into what you will have here? F. F is equal to 2 you will have. Clear? F is equal to 2, means the natural frequency is equal to 2. Therefore, what is the time period? What is the time period? Therefore, the time period t is equal to, it is 1 by f. This is equal to 1 by, what is f? It is 2. This is equal to your fundamental time period. T is equal to 1 by 2. This is what, okay, so this is what the fundamental time period for the given signal. Yes, absolutely, this is a periodic signal and the period of that signal is 1 by 2. That is what. So basically it will be asked in your gate examinations and many government as well as state central competitive examinations you will expect this kind of questions. And let us see one more example so that you will understand better. So we will solve one more example for your better understanding. Here let us say for example, so x of t is equal to, another example, x of t is equal to 3 sine 8 times pi into t. 3 sine 8 into pi t. Let us call you as this equation number 1. Find out the fundamental time period for this given signal x of t. Find out the fundamental time period t. You are asking that what is the time period t. This we have to find out, t, fundamental time period. So given signal is x of t is equal to 3 sin 8 pi by t. Now take the standard form of the definition of the sinusoidal signal. The standard form is nothing but x of t is equal to, it is a sin omega t, because it is given as a sine. Therefore you must take a sin omega t, and further you can write this a into sine, what is omega, expand it, it is 2 pi f, omega is 2 pi f basically, into t. Clear? Now this is what your 2. Compare equation 1 and 2. Compare equation 1 and 2. Therefore on comparing these two, I already told you that you need not bother about the magnitude values. Okay, not required to consider the magnitude values. Then the remaining term you should equate actually. That means it is, this implies what it will, it is sine 8 pi into t is equal to, it is sine 2 pi f into t. So both sides sine they will be cancelled, and then t is also cancelled, pi is also cancelled. 2 4 times means what you will have, this implies it is 4 is equal to, what is this actually, f, same as in previous example. Therefore from this what you will have, time period t is equal to, it is 1 by f, that is equal to 1 by 4. This is 1 by 4. This is what the fundamental time period of this signal. This is the fundamental time period of the signal. And there is another important example actually. Sometimes two signals will be combined together and they will ask you find out the time period, fundamental time period of the signal. Sometimes they will ask you that by combining two different terms like this. Let us consider this particular example. X of t is equal to, x of t is equal to, it is 5 into cos 4 pi t, 4 pi t plus, and then it is 3 sine 8 pi t, 3 sine 8 pi t. This is the given equation. For this, you need to find out the fundamental time period. For this, you need to find out the fundamental time period. That is your question. So if you see this the given signal, you will have actually two terms. This is the first term as well as this is the second term you will have. Because it is a co-sinusoidal signal, this is the sinusoidal signal. Clear? Therefore, so individually from here actually you need to find out the time period t and you can call it as time period t1. And from the second part of this x of t is nothing but this one. From this also you need to find out the time period of this particular and you can call it as t2. Then take the ratio t1 by t2. It should be a rational number. It should be a rational number. If it is a rational number, then the given signal x of t is called a periodic signal. So if you take the ratio of the time periods t1 by t2, you must have the rational number. If you get the rational number, then the signal x of t is called a periodic signal. And then what is the t1 is nothing but the time period of this particular portion. The t2 is the fundamental time period of this particular second portion, means this particular. What is the actual time period of x of t? The fundamental time period of x of t is nothing but t, and that can be given as, you must take the LCM of least common factor of t1 and then t2. If you take the least common factor of t1 t2, that least common factor of t1 and t2 gives the time period of this x of t. Actually it gives the time period of x of t. Clear? Understood? So remember that always. Sometimes or most of the times we will be asked this type of question also. Sometimes they will combine these two terms, they will give, find out whether it is a periodic one. If so, what is the period of x of t? For that, you need to find out the time period of this particular t1. You can call it as t1. Then find out the time period of the second term also. Then you call the time period of this is t2. Take the ratio t1 by t2. You must get rational number. And after that, find out the LCM of those two. Then you will get the time period. Whatever the value comes, that is the time period of x of t. Now, as per this information, find out what is t1. What is t1 and find out, because I already explained you that how the time period is to be obtained for a cosinusoidal signal as well as the sinusoidal signal. We already know that. So if you consider this particular, let us call from here directly I can write, because so magnitude I will not consider. Then if you equate this particular, means cos of 4 pi t is equal to what is our standard form? Cos of omega t. Clear? And it is further cos of 2 pi f t. Clear? Because our omega is 2 pi f, that's why. So again, as we have two terms, in this case for our convenient, you can call this f as f1. Nothing wrong in this, because in the first part of the signal, the frequency you can call it as f1, whereas in the second case you can call that frequency as f2. Clear? So let us consider it as f1, okay, for our convenient. Then so if you equate this with this one, so cos and cos will be cancelled out, t will be cancelled out, pi is also cancels, 2, it is 2 times. Therefore what you will get here, it is 2 here is equal to what you will get here, it is f1 only. Clear? So f1 is equal to 2 only, and from this what you will get, f1 is what is t1, as you have f1 here, and you can write the time period as t1, because t1 is equal to 1 by f1, because as we have considered the frequency as f1, if you take the inverse of that is the time period, and you can call it as t1. This is nothing but 1 by 2. Clear? This is what your t1. This is what your t1. T1 is nothing but the time period of this particular portion. T1 is nothing but the time period of this portion. And similarly, you calculate the time period for the second portion. So if you calculate the time period for the second portion, what you will get actually? Then here, what you will get? So for the second portion, so not required to consider the magnitude. I consider only the sine 8 pi t is equal to, what is the standard form of the sinusoidal? It is sine, directly I will write sine omega t, or otherwise you can write it is sine omega is nothing but 2 pi ft. Here you can take as f2 for our convenience, because the second portion means second frequency. So then this sign will cancels out, and pi will also out, t also out, and then 2, it is 4 times. Therefore what you will get from here is equal to 4 is equal to, what is that actually? F2. And this implies, what is your T2? T2 is nothing but 1 by F2 is nothing but 1 by 4. This is what your T2. Clear? This is what the time period of the second portion means, this particular. So you know the T1 value. Similarly, you know the T2 value also. Clear? So take the ratio now. What is T1 by T2? Now take the ratio. What is the T1 by T2? It must be a rational number. Clear? So T1 is equal to 1 by 2 and T2 is equal to 1 by 4. Clear? Now the ratio of T1 by T2, if you take the ratio, it is T1 by T2 is equal to, what is T1 actually? It is 1 by 2. And then what is T2? 1 by 4. This is equal to 1 by 2 into 4 by 1. It is equal to 2 into 2 times 2 by 1. Obviously, it is a rational. Definitely, it is a rational number. Therefore, it is a periodic signal. The given signal, it is a rational number. Therefore, the given signal is a periodic signal. Your x of t is a periodic signal. Now, what is the time period of x of t? What is the time period of x of t? Now, the time period t of x of t can be obtained as, you simply take the LCM of t1 and then t2. If you take the LCM of t1 and t2. Clear? What is the LCM of t1 and t2? How you can write? It is nothing but what are those? 1 by 2 and then 1 by 4. 1 by 2 and then 1 by 4. So what is the LCM of this fraction? It is very simple. So I think you already aware this, to find out the LCM of two fractions actually. How? So LCM of two fractions can be given as, so I will erase this. So LCM of two fractions. So LCM of 1 by 2 and then 1 by 4. This can be given as, simply you take, it is the ratios basically. Then to find out the LCM, this is the numerators, 1 and 1. These are the numerators. Clear? These are the numerators. This we know. And these two are the denominators. Clear? These are the denominators, you know already. Take the LCM of numerators. This is the formula. LCM of numerators by GCM, greater common factor, GCF, least common factor, LCF actually, least common factor. Okay. And then GCF, okay, greatest common factor of denominator. So as per this formula, numerator, what are the numerator? 1 and 1. Therefore, what is the LCM? LCM of 1 and 1 is nothing but 1 only. Then what is the GCF? 2 and 4. If you take the 2 and 4, the greatest common factor is nothing but 2. 2. If you take the GCF of 2 and 4, then this is nothing but 2. Therefore, this is what LCM actually. LCM of 1 by 2 and 1 by 4 gives 1 by 2. Clear? Therefore, your time period is equal to, therefore, your time period of time period t of x of t is equal to 1 by 2. Time period t of x of t is equal to 1 by 2. Clear? I think you have enjoyed this, you understood this. So this is what the procedure to find out the fundamental time period of any given signal. Okay, so I will finish off here, and we will continue with some more examples on this, and then subsequently we will see the another remaining part of the classifications of the signals, right? See you.